Okay, so today we're going to be talking about how do you find the area of a triangle. And so, normally the formula for area of a triangle is area is equal to, and I should use a marker. Area equals 1/2 times base times height. Well, if we call the base B, okay, you can arrange any triangle any way. The base is the bottom, and the height is going to be this length right here. And so what we want to do is we got to find the height. And so if you want to find the height is going to be measured by doing SOHCAHTOA. Okay, so if you want to find the height, you could do the sine of angle C is equal to the height over A. Okay, so to find height, okay, this is what we're going to do. We're going to say sine of C is equal to H over A. If you cross multiply, you're going to get the height equals A times sine of C. And so we're going to use that in place of the height here. So we're going to do A times the sine of C. And we can do that. 1/2 times the base times, instead of the height, we're going to do A times the sine of C. And so abstractly, we can say that the area is equal to 1/2 AB sine of C. And then, so that's one formula. Now it says, can you find two more? Well, that's kind of weird, but let's try it. Okay, so if we redraw the same triangle, and so if you call this A over here, and this is B, and you say this is C, and you drop an altitude, and if you know the bottom is the length of B, and then again, we need to know the height, and then let's lean into the left angle. So to find this, okay, the length of height, if we know this is side C, we could do if the area of this triangle is equal to 1/2 times base times height, and instead of height, we're going to represent the height in terms of the measure of angle A. So we're going to do the sine of A is equal to H over the length of C, cross multiply. So H equals sine of A times C. And so, or C sine of A. Okay, so we're going to do C times sine of A. So another way you could find the area of that exact same triangle is to do area is equal to 1/2 BC. Let's see, sorry. And we could say times the sine of A. And what we're doing is we're saying the area, and I should write area. And so it's kind of weird, like if you don't know the height, you can use trigonometry to find the H, of course, okay? And so that's what we're doing here. And for the other way, it's just kind of awkward. And so with any triangle, you can arrange it so any side is the base. So if you call this side right here the base, and then you find the height that's perpendicular to it. Okay, so we can do it. So you do 1/2 times, so the area equals, okay, so each of those are area equals. Area equals 1/2 times the base, and the base is side A, and then times the height. And again, instead of the height, we're going to do trigonometry to calculate that. So do the trigonometry to calculate that. I'm going to reach over to angle A, angle B. So if you want to find the height, I'm going to say the sine of angle B is equal to H over side C. So it'd be height equals C times sine of B. And so instead of the height, I'm going to do C times sine of B. And what we're doing now is we're just kind of deriving 3 area formulas that you can use as alternate things, and we're going to officially teach that later in the lesson. We're also saying, can we come up with the law of sines, which we are going to use quite a bit. So one of the area formulas is going to be take 1/2 times AB sine of C. That's the first one. The other one is 1/2 times B times C times sine of A. This last one would be area equals 1/2 times A times C times sine of B. And so we are coming up with 3 alternate forms. Again, they look terrible, and I'll show you how you'd use them actually, because they're actually helpful. And we're saying, well, they all find the area of the same triangle. They're kind of weird, okay? But it's like if you don't know the height, you've got to use trigonometry to find it. And so if we set all 3 of these formulas equal to each other, because we could, okay, they all would give the same area. And you would say 1/2 AB sine of C. And then that equals, for the same triangle, 1/2 times B, side B times side C times sine of A. And that equals 1/2 AC and then sine of B. So I just took those three formulas and said they must give us the same answer. Okay, and so you're like, well, that's disgusting. Yes, it is. And so what we'll do is we're going to divide all three of these equations, or all three of these expressions by 1/2 ABC. Okay, you're like, awesome. Could it get any worse? We're just trying to find the formulas. 1/2 ABC. Divide by 1/2, because you can. Divide by 1/2 ABC. And then if you do that, the 1/2s, of course, reduce. Same with the A's and same with the B's in this case. And this one, when the halves reduce, the B's will reduce and the C's will reduce. And then the last one, 1/2, and then the A and the C reduce. And you're left with the law of sines. The law of sines would be, and I'm going to rearrange, you could say the sine, I'm going to start with the middle one right here. Sine of angle A over the length of side A is equal to the ratio of the sine of side B over the length of side B, which is equal to the sine of side angle C over the length of. What is even happening here? Well, the story is this, that when you were in geometry, you learned that the relationship between the angles and the sides of a triangle are going to be proportional, meaning the bigger the angle, the bigger the length of the side across from it. Okay, and so we kind of derived that formula and also talked about how you find the area by saying, guess what? Not only are the angle A and the length of side A related proportionally, but it's actually specifically related to the measure of sine of A. Yes, SOHCAHTOA kind of, but there's no opposite in hypotenuse. It's just going to be the measure of side A, okay, is proportional to the sine of that angle across from it. Okay, and so, and same with side B. Okay, if you took the sine, yes, on your calculator, it's a value. Yes, it's related to SOHCAHTOA, but sine is just a function. Okay, the sine is just a button you can put. It's a ratio that you can find on your calculator. The sine of angle B is proportional to the length of side B across from it. And then that also in the same triangle, if you look at C, the length of side C is proportional to the sine of angle C across from it. So this is called the law of sines, and saying it's banking on the angle, the measurement angle is directly related. The sine of that angle is related to the length of the side across from it. And so we're going to use that to find missing sides and angles in triangles when we don't have a right triangle, because SOHCAHTOA only really works if you've got a right triangle. And so we're going to kind of write that. So you can actually write that right here. Okay. And this works, if you've got angle, side, angle, angle, side, or side, side. Well, you just have to have a pairing. Okay. And I'll show you how that works. Okay. And so we kind of came up with, I'm not going to ask you to derive that formula. Okay. I'm going to ask you just to use the law of sines to solve non-right triangles. And so let's begin with that. Okay. We'll come back and talk about area in a second, but let's talk about solving these triangles. And so in order to solve these triangles, okay, we're going to start with example 2. The length of an angle and the related side across from it are going to be related by the law of sines. Okay, so you can't do SOHCAHTOA because it's not a right triangle. But what we're going to do is we're going to say, okay, well, the measure of this angle is directly related to the length of side D, who's across from it. And so you can write the sine of 57 is related to the length of D. Okay, well, that's something we want to find, but we know a ratio that is actually true. We know that the measure of angle that's 24 degrees is over that the side across from it. So I'm not talking very well. So let's see if I can get it right. So the sine of 24 degrees, that's E, is proportional to the length of the side across from it. It's the same proportion, because it's the same triangle, as another angle, and that side of that angle is related to the length of the side across from it. And so if we want to find the length of side D and we don't have SOHCAHTOA going on, we can use the law of sines because we have a proportional angle and its related side across from it. And so if we cross multiply and solve this, we get 24 sine of 57 equals D sine of 24. Divide both sides by the sine of 24. So D, the length of side D, is going to be the quotient of those two items. 24 times sine of 57 over sine of 24. Find that quotient in your calculator and you get D, the length of side D, is equal to, let me find it. is going to be 49.5 units. And that's pretty impressive. We can use that law of sine to help us find missing sides and angles. And so another thing we can know is, well, guess what? To find the measure of angle F, so the measure of angle F, okay, we've got to do 180 minus 24 and also minus 57. So the measure of angle F is equal to 99 degrees, which is kind of cool. And then we're going to use that to be like, okay, well, I want to find the length of side F. So I have to do the sine of 99 degrees over the length of side F. And in these non-right triangles, you have to sometimes use data you found along the way. Okay, but just document what you've done. Now, a proportion we know that we were given is the sine of 24 goes with the length of side 24 across from it. So if we cross multiply and solve this, we get 24 sine of 99 equals F sine of 24. Divide both sides by sine of 24. If you find that quotient, you're going to get the measure of side F. So F is approximately equal to 58.3 units. So we used the law of sines to help us solve this triangle, okay? Law of sines works great if you have a matching angle inside across from it. Okay, so let's do another one over here. Let's do example A. So the first thing is, let's find the measure of angle C. If you do 180 minus 86 and 27, the measure of angle C is equal to, let's see what that's going to be, 67 degrees, okay? Just, make sure you document what you're doing. And then we have a pairing now. We know that the sine of 67 goes with 19, just like the sine of 27 goes with side B. Okay, so we can cross multiply and find that. So B sine of 67 equals 19 sine of 27. Divide both sides by the sine of 67. Okay, so, and then B, oops, I need a pen. B would be approximately, let's see, 9.37 units. Okay, and your last side that you'd have to find, we could call that side A. So you say, well, sine of 86 over side A equals, and then go with the side ratios. Sine of 67, it goes with 19. If you cross multiply and solve, you're going to get the length of side A to equal 20.6 units. Okay. I want to talk about how you draw your own picture, because that's going to be part of the lesson as well. It's like, can you look at this and be like, I don't know what this looks like? Well, look at what you see. And actually, I did a typo here. This should say the measure of, let me see what that should say. I'll fix it right now. The measure of angle E is 50 degrees. So you've got a triangle, and one of the angles is angle E is 50 degrees. And then that the length of side E is 7.6. That's across from it. And then that the length of side D is 4.3. So that means an angle D has a side across from it that's 4.3. And we're going to have to find the measure of angle D. We don't know what the other letter is. Maybe it's like F. Okay, and we can name it whatever we want. We just have to solve the triangle. Okay, and so I think the big thing is look for the capital vertices, look for the baby letters, and they're across from each other. So the ratio is the sine of 50 goes with 7.6. And then, so that would be the given angle E and the side of E across from it. But what we don't know is the measure of angle D or the measure of angle F. So we're going to have to use the sine of D goes with the length of D, which is going to be 4.3 across from it. And so this is a little bit trickier to solve, but it's not that big a deal. You just cross multiply. You say 4.3 sine of 50 equals 7.6 sine of D. You're going to divide both sides by 7.6. And the question is, how do you get just plain old D? Well, we're going to use inverse sine. So use inverse sine to both sides. And so you're going to get the measure of angle D is approximately equal to the inverse of that fraction. So just lump the whole thing in your calculator, and you get your answer to be D to be about 25.68 degrees. And then with non-right triangles, you're going to have to use data that you found throughout the question. So if you do 180 minus 50 and 25.68, that means that the measure of angle F is approximately 104.32 degrees. And then we'll have to use the law of sines yet one more time to find the length of side F. So the sine of angle F, which is 104.32, over the length of side F, which we don't know, is equal to the sine of 50 over 7.6. And then if you cross multiply and solve, you find the length of side F to be approximately 9.61 meters. Okay. And so it's just good to be able to say, we can write these ratios and can we solve it? Do we know the algebra to help us solve these guys? Okay. Cross multiplication is what you do. If you need to find an angle, use inverse for that value. And then the last thing we got to do is find the area. And so there are 3 formulas to find area, and we found those. But I think the big thing is I don't want to use all 3. Okay. And so I think the big thing is I focus on the last one. Okay. And so if you look at the last one will help you to be able to say, if I know 2 sides and the angle between them, I can find, the area real quickly. Okay. It's in lieu of actually doing trigonometry to find the height and then doing 1/2 times base times height. The formula for the area of a triangle is still and always will be 1/2 times base times height. But if you don't know that, but you know 2 sides and the angle between it, you're really golden. Okay, what do you mean, woman? Well, notice if I know 2 sides and I call them A and B, okay, and then if you know the measure of the angle between it, I call that angle C. Okay, notice they're not across from each other. How do you know that? Well, because they don't match in any letters. A and B would have A and B angles across from them, and angle C would have side C. So you know 2 sides and the angle between them. You can find the area by just doing 1/2 times A times B times sine of the angle between them. So I just memorize one formula when I'm finding area. So if you know 2 sides and the angle between them, you can just call them side A and B, and you call the angle in between them angle C. Okay, and so it's side angle side. So you do 1/2 times 8 times 12 times sine of 86, and that'll give you the same area as if you went through trigonometry to find the missing height, and you found the area of that triangle. So let's check out what this would be. The area this would be 47.88 feet squared. This one here, you do 1/2 times 3 times 5 times sine of 40. And so that'll give you the area of that triangle. And so that area is going to be 4.82. And that would be meters squared. And the last one, you need 2 sides and the measure the angle. Well, I don't know that yet. Well, if you subtract the 2 you know from 180, you're going to get that angle, and that'll be 60 degrees. Okay, so again, 1/2 times 120 times 132.8 times sine of 60 degrees. That'll give you the area to be, that's a big number. Let's see if I can read my writing. 6900.49. And that's going to be meters squared. I believe that I read that correctly. All right, so that's the answer, and that's how you can find the area if you don't know 1/2 times base times height. You can always do trigonometry, drop an altitude and find the height, and do that original formula 1/2 base height, or you are welcome to use 1/2 AB sine of the angle between them. All right, thank you so much. Have a good day.